Hello, I'm Patrick. Welcome to this very special tour of our solar system. I must apologise if our ship seems a little, how shall I put it, over-familiar. The engineers seem to...
Hey, maybe I am just a bag of chips, but you're not exactly three-dimensional yourself.
All right, no need to get upset. Perhaps this will be a good moment to whet your appetite by showing you some of the highlights of this trip. See that? Use your controller to move the cursor above it. Then click on it by pressing one of the action buttons on your controller. Go on. No? All right, I'll show you. It's very simple.
Adventures in space! Sightseeing in the solar system is a stunning experience. As you cruise through the cosmos and prowl past the planets, here are some of the astronomically amazing attractions on offer. You can circumnavigate the sun, visit volcanic Venus, race over the red planet, jaunt around Jupiter, saunter past Saturn, navigate to Neptune, trek out to Triton, caper with the comets, take a tour or play a game. Whatever you do, wherever you go, it's fun, fun, fun in the solar system!
Ah, hello again. Sounds exciting, doesn't it? Don't forget, you are in control. You can fly this spaceship all round the solar system. The navigation system is simple and easy to use. You can call it up wherever you are, anytime you want to change course or see something different.
Just click here and then select the destination of your choice. Any of the 9 planets, the sun, the asteroids, or the comets.
And the ship will fly you there. Won't you, ship?
I sure will. But if you want to stay where you are, click here to put the map away. Or, if you'd like a change from flying around...
You'll find the tours and games in your handy travel pack.
Yeah, we've got a couple of games that are real good fun. And then there are 2 tours for you to sit back and enjoy. Now, what next? How about these controls? Use them to stop and start and to jump backwards and forwards. This one's a bit different. Use it to get back where you came from, sort of like retracing your steps.
And don't forget these. Whenever you see one, you can click on it if you want to explore a little further.
Well, that just about wraps it up. Have we explained everything?
One last point to remember. Next time you take this holiday, you can choose to skip part or all of this introduction simply by selecting the map or travel pack and taking it from there. Right, we are ready to begin. Are you all set, ship?
My engines are primed. Let's eat some space.
Good. Now all you have to do is to bring up the map and decide just where you want to go. I'll be here all the while to tell you what's what. Have a wonderful time.
Gravity Golf! Play golf all around the solar system on our fantastic 9-hole course. Different planets, different moons, different gravities. Change the direction of your shot with the arrow controls and hit your ball, hard or soft, by clicking at different places along the fire bar. Good luck with that hole-in-one! Hole 1, Venus. Hole 2, the moon. Lost in space! Lost in space! Lost in space! Lost in space! Hole 3. Earth. Hole in 1! Hole 4. Mars. Hole 5. Europa. Lost in space! Lost in space! Lost in space! Lost in space! Hole 6. Io. Hole 7, Jupiter. Hole 8, Uranus. Hole in 1! Hole 9, Neptune. Hole in 1! Round over. Planet Ball! Fire your asteroids into the big black hole, but watch out for the planets. Don't hit them, just use their gravity to help score a hit. Rotate your ship with the arrow controls and fire fast or slow by clicking at different places along the fire bar. Away you go! Level 1. Level 2. Level 3. Level 4. Level 5. Level 6. Level 7. Game over, man!
Early man thought that Earth was the center of the universe, and that the sun and all the other things in the heavens formed a dome around it. The stars were fixed on that dome, but the planets wandered about. In fact, the word planet means wanderer. A complicated arrangement of celestial cogs and gears was used to explain the way some of the planets appear to loop back upon themselves. We now know that the stars do not form a literal dome above us, but are scattered around the infinite sky at varying distances. And we know that Earth, like the other planets, orbits around a star, the Sun. Some of the planets are between Earth and the Sun. Others are further out. It is this that leads to their strange movements in the sky, not any complex mechanical contrivances. Despite appearances, the solar system is not a constant thing, and it has not existed forever. Some 4,000 to 5,000 million years ago, a slowly rotating accumulation of matter called the solar nebula condensed. The matter in the solar nebula gathered together unevenly. The strongest concentration was at the center. The energy held here at the heart of the disk made it ignite to form a star, where hydrogen fuses into helium with the release of immense amounts of energy. Away from the center, the planets formed and rotated around the star. The inner planets were so hot that molten rock erupted from their interiors, forming volcanoes and covering the surfaces with lava flows. Planets can be a long time cooling, and volcanic processes continue to this day, but to a much lesser extent. The early solar system was an active and violent place. Meteorites often fell on the primeval surfaces of the Earth, Mars, Venus and Mercury, adding to their growing mass and producing immense craters. No body in the solar system will have been immune from these impacts. The crater-scarred surfaces we can now see on the Moon, Mercury and the satellites of the outer planets are evidence of this. Further out from the Sun, where there wasn't so much heat, giant balls of gas developed, forming the outer planets, like Jupiter and Saturn. These planets have strong gravitational fields, and so attracted many satellites. But close in, their gravity was so strong that matter was unable to form into moons, and instead spread out to form rings. Jupiter, the largest planet of all, has such a strong gravitational force that it prevented the formation of a planet between itself and Mars. The result, the asteroid belt. And at the very edges of the solar system, lighter icy particles formed comets. These occasionally swooped towards the Sun, moving around it in long, slow orbits. Eventually, the Sun will use up its hydrogen fuel and expand, becoming a red giant and swallowing up the innermost planet Mercury as it does so. With its brightness increasing 1,000 times, it will turn Earth into a burnt-out wasteland. The Sun will then shrink and cool, becoming a white dwarf, and the solar system will be dead, with just the husks of planets remaining. The solar system is now 4,500 million years old, and the Sun will carry on burning happily for another 5,000 or 6,000 million. So we do have a few more years to look forward to. The mythologies and beliefs of ancient Greece and Rome have given us names for most of the planets and moons in our solar system. The gods of these mythologies were remote and powerful figures, and so were easily associated with the bodies observed moving mysteriously through the unfathomable night skies. The oldest object of wonder and worship in the sky must have been the Sun, the star at the center of the solar system. It's not surprising that people looked on it as a god, its light and heat being so essential to life. The ancient Egyptians worshipped the Sun as the god Ra, the Greeks as Helios, and the Romans as Apollo, son of Jupiter. Apollo was also the god of music, medicine, poetry, and all the fine arts. A very busy god. Mercury, messenger to the gods and patron of travelers and thieves, gave his name to the planet closest to the Sun. Known to the Greeks as Hermes, Mercury sped about with wings on his heels, so it's fitting that this planet, which moves the fastest, should be named after him. Venus was the goddess of love and beauty, of spring and new beginnings. The Greeks called her Aphrodite, a name which means born of the foam. Venus the planet can be seen in the western sky after sunset and in the east just before dawn. It was once thought that Venus might be a pleasant, even heavenly world. In fact, it's more like hell. Earth's name is firmly based in reality rather than mythology. It is descriptive of the ground beneath our feet. and the planet is also known as Terra, as in terra firma. The biosphere, the region of Earth where life exists, is often known as Gaia, after Gaia, the Earth goddess. Mars was named after the Roman god of war because it looks so very red. But far from being hostile, Mars is more friendly than any other planet, except of course Earth. And there are no hordes of interplanetary warriors waiting there, no Martians. The 2 moons of Mars were discovered in 1877 and were named Phobos and Deimos, that is, Fear and Terror. Some say that they were the sons of Mars who fought alongside him. Others say they were the horses that drew his chariot. Jupiter, also called Jove and Zeus, was the ruler of Olympus, the legendary mountain home of the Greek gods. It's appropriate that his name was given to the largest and most massive of all the planets. Jupiter had a foul temper, and when angry, he would fling thunderbolts around. Perhaps these are the lightning flashes we see in the planet's clouds. Greek and Roman mythology is full of the tales of Jupiter's love affairs. To avoid being found out by Juno, his wife, Jupiter used to turn himself or his lovers into animals. He ran off with Europa while disguised as a bull, and he turned Io into a heifer. As an eagle, he captured Ganymede, a beautiful youth, whom he trained to be his cupbearer. Europa, Io, and Ganymede are the names of 3 of Jupiter's moons. Saturn was well known to the ancient stargazers. They named it after Jupiter's father, who ruled Olympus before his son deposed him. Saturn ate all his children to prevent them overthrowing him. But that didn't stop them. They were immortal. The moons Iapetus and Hyperion are named after 2 of the Titans, Saturn's brothers and sisters. And of course, Titan itself is another moon of Saturn. Others include Rhea, his wife, Enceladus, a giant who tried to dethrone Zeus, and Tethys, wife of the Titan named Oceanus. The planet Uranus was discovered by William Herschel, who wanted to name it after his king, King George III of England, but that wasn't allowed. Mythological tradition prevailed, and the name Uranus, after the first ruler of the gods, was chosen. Herschel went on to discover Titania and Oberon, moons named after the king and queen of the fairies in Shakespeare's play A Midsummer Night's Dream. Uranus's other moons also have names of literary characters, many of them Shakespearean: Cressida, Puck, Cordelia, and so on. After he had overthrown Saturn, Jupiter and his 2 brothers divided the universe between them. Jupiter ruled the land, Pluto took the underworld, and Neptune the seas and oceans. It is only right that this apparently serene blue planet should be called Neptune, after the god of the seas, and the largest moon was named after his son, Triton. When the outermost known planet was discovered, someone suggested calling it Minerva, after the goddess of wisdom. But an 11-year-old girl, Venetia Burney, suggested Pluto, who was the god of the underworld. Pluto is so far from the sun that it must be a gloomy place. Charon was discovered in 1977, and what could be better than to name this, Pluto's moon, after the sinister ferryman who took departed souls across the river Styx. Charon carried them to Pluto's kingdom for a fixed fare, 2 coins laid on the eyes, a journey for which there is no return ticket, yet.
Here we are. It's big, it's bright, it's the sun.
The only reason that the sun outshines all the other stars is that we are so much closer to it than all the other stars.
Ah,
In reality, it's a very average and ordinary star, just like billions of others in the universe. Astronomers classify it as a dwarf star rather than a giant.
well, it may be ordinary and average, but it's pretty important to the planets in the solar system.
Of course. And although I say it's ordinary, you should never look at it directly with the naked eye or with any telescope or binoculars. If you do, it will blind you. Apart from light and heat, the sun also sends out all sorts of harmful radiation and particles which can be used to get quite accurate pictures of its surface, where the temperature reaches over 5,000 Celsius. The sun is powered by nuclear reactions in its core.
I hardly need add that we're not even going to think about getting too close.
One of the simplest ways of looking at the sun without looking at it is to point a telescope at it without looking through the telescope.
Looking at the sun without looking at it?
Yes, you simply hold a white screen at the end where your eye would normally be, but at a greater distance from the eyepiece. The telescope then acts as a projector, projecting the sun's image onto the screen.
Oh, I get it.
Here's a drawing Galileo made several hundred years ago using this method. You can see sunspots quite clearly. During a total eclipse, when the sun's bright surface is blocked out by the moon, it's possible to see the fainter prominences round the edge, as well as the corona spreading out in all directions. I wonder, have you ever seen a solar eclipse?
They must have worried people who didn't know what was going on, like a cosmic power cut.
These pictures were taken from an aeroplane flying over Finland during an eclipse on Earth in 1990. You can see them from Earth because of a strange coincidence. It so happens that from Earth, the Sun and the Moon look almost the same size. The Sun's diameter is 400 times that of the Moon, but the Sun is also 400 times further away.
Right. It's all to do with perspective.
I wonder. It's possible to see the fainter prominences round the edge, as well as the corona spreading out in all directions. The sun radiates in all regions of the electromagnetic spectrum, so an obvious way of looking at it is to use some of this other radiation, such as X-rays. X-rays have to be monitored from space, because they can't penetrate the Earth's atmosphere. This is an X-ray movie of the Sun. The bright areas are X-ray loop structures, which correspond to large sunspots seen when the sun's looked at in white light. You can also see occasional solar flares, which show up as a short-lived brightening of the X-ray structures. As X-rays. X-rays have to be monitored from space, because they can't penetrate the Earth's atmosphere. Nuclear reactions in its core.
The Sun is 25,000 light-years from the center of the galaxy. That's a long way. So our solar system isn't exactly in the middle of things, galaxy-wise.
I'm afraid not. The Sun takes 225 million years to revolve around the center of the galaxy. That's what's called one cosmic year.
And my calculations show me that the Sun is traveling at 220 kilometers per second. Okay, more statistics. Mean axial rotation period, 25.38 days. Equatorial diameter, 1,390,000 kilometers. Density, 1.41. Mass, 332,946 times that of Earth. That means the Sun is much more massive than all the other members of the solar system combined.
More than that. The Sun accounts for 99% of the total mass of the solar system.
Wow! Gravity is 27.9 g. And the surface temperature is approximately 5,500 Celsius.
And the surface temperature is nothing compared with that of the core. The temperature there is 14 to 15 million Celsius. Nuclear reactions in its core. Nuclear fusion reactions only take place at the very high temperatures and pressures found in places like the centers of stars, exploding nuclear bombs.
And under experimental conditions.
In the reaction, hydrogen nuclei, actually just single protons, fuse together to form helium nuclei, which consist of 2 protons and 2 neutrons. In each fusion reaction, a little mass is lost and a vast amount of energy is released. Einstein explained this with his famous equation E equals mc squared. In this way, the Sun loses about 4 million tons of mass every second.
If a lot of energy is released when a little mass is lost, then when 4 million tons of mass are lost every second, the energy released must be phenomenal.
Yes, but remember that 4 million tons isn't much by solar standards. There's a great deal more where that came from.
Glad to hear it.
Fusion reactions also produce particles called neutrinos, which the Sun sends out in vast numbers. They have no electrical charge and virtually no mass, so they are very difficult to detect. Nuclear reaction. The constant stream of atomic particles emitted by the Sun makes up what's called the solar wind. It never stops.
When you say emitted, does it come out from all over the Sun?
Remember the Sun's outer atmosphere, the corona? This is made up of very rarefied gas, millions of times thinner than, for example, the Earth's air. Here and there we find regions of even lower density, known as coronal holes. And it's through these holes that solar wind escapes. It blows for a great distance, past all the planets and on into outer space. It's the solar wind that causes comets' gas tails always to point away from the Sun, so that, for example, when a comet's moving away from the Sun, it actually travels tail first.
Ah, I've always wondered about that. You'd expect the tail to stream out behind the comet, like your hair when you're riding a bicycle. But if the wind is blowing, say, from one side of you...
That's the idea. When the solar wind encounters planets, Earth for example, particles are drawn down into the atmosphere. This is especially so near the magnetic poles and causes amazing displays of aurorae, or polar lights. On Earth, these are known as aurora borealis in the northern hemisphere and aurora australis in the southern hemisphere. Nuclear reactions in its core.
I hardly need add that we're not even going to think about getting too close.
Mercury looks small, doesn't it?
Yeah, why's that?
Because it really is small. At least, it's small by planetary standards. It has a high temperature because...
It's so close to the Sun, right?
Right. That heat, a low mass, and low gravity all mean that Mercury isn't able to hold on to an appreciable atmosphere. In fact, its atmosphere is so thin that for most purposes we can forget it. And being so close to the Sun, it makes it very difficult to get close enough to the planet to get much good information.
Too hot to get too close, huh?
Yes, we have some pictures of the surface, but not a complete map. At first glance, it looks rather like the Earth's moon, all those craters. Also, just like the moon, it shows phases, apparent changes of shape from new to full. It was once thought to have one side in permanent darkness and the other in permanent sunlight, with a narrow twilight zone in between. But we now know that this is wrong.
Okay, here she is. Venus, second planet out from the sun.
Venus is what's called a terrestrial planet, and is much the same size as Earth, its next-door neighbour.
Ooh, kind of smoggy, isn't it?
Yes, you can't see Venus's surface from here because of the very thick, cloudy atmosphere. People have had to use a radar to find out just what the surface looks like, because the atmospheric pressure at ground level is enough to squash most spacecraft.
Whoa, heavy.
I thought you wouldn't like the sound of that.
Approaching Earth, also known as Terra, also known as home.
Earth is the largest of the 4 terrestrial planets, just a bit bigger than Venus. It has a thick but largely transparent atmosphere that contains a considerable amount of water vapor, often in the form of clouds.
Often in the form of rain, and usually when you're planning to go out.
Water is everywhere on Earth, in the oceans, covering more than half the surface, and in the polar ice caps, as well as in the atmosphere. In fact, water has played a major part both in the evolution of Earth's landforms and the evolution of life. One of these life forms has actually set foot on Earth's only satellite, the Moon, but it didn't stay for long.
Of course they didn't just grow wings. They wouldn't have got there without a spacecraft like me. Here it is, Mars, the red planet. Say, will I see any Martians? You know, spooky monsters with big goggle eyes and slimy tentacles?
Only in science fiction. In fact, Mars would be a relatively friendly planet for Earth people. It was named after the old god of war because people associated its red colour with blood. It's one of the smaller planets in the solar system, and it has 2 small satellites, Phobos and Deimos. Because of its low gravity, Mars can hold on to only a thin atmosphere. It has some clouds, but no liquid water on the surface. The pressure's too low for water to exist as a liquid.
What about those things that look like dry riverbeds?
That's just what they are. There must have been liquid water there in the past, but now it all exists as ice.
And how about those long dark patches? They look as though they could be kind of damp.
Yes, they were once thought to be seas, but now we know that they're not. Even though the whole of Mars is dry, the redder areas are usually referred to as deserts. Not sandy, but dusty, and very, very cold. Astronomers used to think that there ought to be a planet moving around the Sun between the paths of Mars and Jupiter because of a curious relationship called Bode's Law. Instead, they found thousands of asteroids.
Well, I hope they weren't too disappointed. At least they found something.
It's thought that no large planet could form in this region because the strong gravitational pull of Jupiter would tear it apart. This is Gaspra, a pretty typical asteroid. It's 32 kilometers long, irregular in shape, and pitted with tiny craters. The first asteroid to be found was discovered in 1801 by Piazzi, the director of the Palermo Observatory. It was named Ceres, after the goddess of Sicily. Now we know of so many that they're being named after much more modern characters. For example, asteroid number 2309 is called Mr. Spock.
But, Captain, that's very illogical.
By the way, if you ever discover an asteroid, you'll be entitled to name it.
So, what are asteroids made of?
I think it's reasonable to say that they're made of much the same stuff as meteorites. And we know about those because, of course, they've crashed into Earth. Some are carbon-rich, some are stony, and some rich in metals like iron. Who knows, we may even be mining them one day. Most of the craters around in the solar system have probably been made by meteorites. The best-known crater on Earth is in Arizona. It's over 1 kilometer wide and is called Meteor Crater. And there's a serious suggestion that an asteroid, or meteorite, did actually strike the Earth about 65 million years ago, causing such a dramatic change in climate that the dinosaurs became extinct. And much more recently, in 1908, there was an impact in the Tunguska region of Siberia, the Blue Pine Trees Flat, for an area covering many square kilometers. That could have been a very small asteroid, a very large meteorite, or even a part of an icy comet. We're not sure. I'm glad you've decided to put Jupiter on your itinerary. It would be a great pity to miss it. It's the senior member of the Sun family, and it's more massive than all the other planets put together.
Even so, it only has 1/1047th the mass of the Sun.
It's quite unlike the small, solid terrestrial planets, such as the Earth and Mars.
So, it's big, but it's not that solid.
Yes, it's known as a gas giant, like Saturn, Uranus and Neptune. You can see all sorts of features in Jupiter's upper clouds. There are dark streaks which we call belts. There are bright zones. And of course, spots, such as the spectacular Great Red Spot. Jupiter also has a ring system. See those two orange lines, the straight ones toward the bottom of the screen?
The blue curve is the planet's edge or limb.
And of course, Jupiter has a whole family of moons. 4 of these are about the size of the terrestrial planets. I always feel that one of the main attractions of this particular tour is that we see so many different kinds of worlds. Mercury and the Moon have their craters. Mars is volcanoes. Jupiter is belts and spots. But for sheer beauty, surely nothing can rival Saturn. Just look at it. Those rings are just glorious.
Oh, they're beautiful. They look pretty solid, too.
Ah, but they're not. Saturn is a massive planet, and its gravity is too strong for solid or liquid rings to survive. Not surprisingly, Saturn also has an extensive satellite family. One large attendant, Titan, several medium-sized moons, and some very small ones. Titan is of special interest because it has a dense atmosphere. But don't forget the yellow globe of Saturn itself. Most of it is gaseous, a great deal of hydrogen together with a bit of helium.
Looks like there's a lot going on down there.
Yes, it's very active. It has streaks and storms and spots. Though I admit, there's nothing comparable with Jupiter's Great Red Spot.
Okay, approaching Uranus. Kinda downbeat looking place, isn't it?
Yes, I was a little surprised when you opted to visit Uranus. Not the most spectacular planet in the solar system. No brilliant colors, no obvious clouds. Only thin, dark rings.
How long have we known about this place anyway?
Uranus was discovered in 1781 by William Herschel, using a telescope he made himself.
Clever guy. Hey, this place is about the same size as Neptune, isn't it?
Yes, they are almost twins, but the two are not identical. Uranus has no appreciable internal heat source and is not so dense or so massive as Neptune.
No central heating, huh? But plenty of satellites, I see.
Yes, 15 in all, mostly named after Shakespearean characters. Even Titania, the largest, is smaller than Earth's moon, and none of them can hold on to any trace of atmosphere.
Approaching Neptune, the blue planet.
You know, you could say that there are two blue planets in the solar system.
There are? What's the other one?
Earth, which, when seen from a distance, is decidedly bluish. But, of course, you're right. The true blue planet is the outermost gas giant, Neptune.
Okay. So what do we know about Neptune, the bluest planet?
We used to know very little, but since 1989, when NASA's Voyager 2 space probe flew past, we've learnt a great deal more. It's just about the same size as Uranus, slightly smaller, but appreciably more massive. It's a much more dynamic planet than its twin, no doubt because, unlike Uranus, it has its own source of internal heat. In fact, the cloud temperatures of these two are very similar, even though Neptune is so much further from the Sun.
Neptune's central heating, huh?
Before Voyager 2 took a look at Neptune, only two satellites were known, Triton and Nereid. Voyager found 6 more, and also discovered a somewhat obscure system of complete rings, not arcs as they'd been previously thought to be.
Now approaching Pluto. Say, is there any reason why they named this planet after Mickey Mouse's dog?
They didn't, it was the other way around. Mickey's dog was named after the planet. Pluto the planet was discovered in 1930, and Pluto the dog was named in 1931. Originally, Pluto was the ancient god of the underworld.
Oh, so you could say it was an underdog.
No, you could not. I must say, there's more to say about this planet than there is to see. It's very small, and in fact, it may not even be worthy of true planetary rank.
Aren't there 2 specks of light there?
Yes, the faintest speck is Pluto's companion, Charon. I say companion, not satellite, because Charon is more than half the size of Pluto itself. When you told me you wanted to look at a comet, I wasn't sure what could be done. Comets aren't the most predictable things. But at least I can show you some that have passed through recently.
Here you go. Comets can look very dramatic, can't they?
In ancient times, comets were seen as omens of death, disaster, and divine displeasure, and often caused great alarm. Of course, their nature was unknown, and they can be very striking.
If one did strike, you'd be right about the death and disaster. Do we know what they're made of now?
Well, comets are basically great, dirty snowballs, lumps of ice mixed with solid material. But most people picture them as having gleaming heads and long, brilliant tails. Some really are like this, but many comets never develop tails at all. Those that move around the Sun in orbital periods of less than a few centuries are called short-period comets. Most of the really brilliant comets take thousands or even millions of years to return, so we never know when to expect them.